just gonna be explaining bond types and polarity for chapter 7. So F versus Cl, it is polar because it took the electronegativity of each atom. F's electronegativity is 3.98, Cl is 3.16. You take the difference of the two, which is 0.82. That's polar because it's greater than 0.5. F is more electronegative. I also wrote like the little chart on the side. Non-polar is always going to be less than 0.5. Polar is 0.5 to 1.7. And ionic will be more than 2. Let's see. Cl versus S. C equals 2.55 and S equals 2.58. The difference is 0.03 electronegativity. It's not polar because the difference is less than 0.5. Fun fact, S is more electronegative than C carbon. And then H versus Br. H hydrogen's electronegativity is 2.2. Br is 9.96. Difference of that is 0.96. Br is more electronegative, and then it's a polar too. So this is polar, nonpolar, polar, nonpolar. This one is nonpolar because it's one element, oxygen. Oxygen is also a diatomic molecule as well. So nonpolar. And then Cl versus S. Cl 3.16. And then S is 2.58 for their electronegativity. Take the difference of that is 0.58. It's polar. Cl is more electronegative as well. Again, chart. And then let's see, drawing the Lewis structures for SiO2 and H2S. This one is a linear shape. It's nonpolar. Both of the charges are going away from the central atom. There's also no lone pairs remaining. The charges, they pull away, so then they also cancel out. It's symmetric. There's even electron distribution, so which all contributes to the non-polarity. And then for this one, was it H2S? Sulfur has 2 lone pairs, which is a bent shape. The 2 lone pairs are repelling the hydrogen atoms as well. The lone pairs and the bent shape and everything is all contributing to the polarity of the molecule. And then give one example of polar linear molecule. How is it different from CO2? These are 2 linear molecules. This one is polar though because I took the electronegativity of each atom. S equals 2.5, and then carbon is 2.5, and oxygen is 3.5. So the bond between sulfur and oxygen is nonpolar because the difference is 0. But the difference between carbon and oxygen is 1 because oxygen is 3.5 minus 2.5, which equals 1. So oxygen and carbon's bond is polar. And if there's one polar bond, then the overall molecule is going to be polar. So therefore, polar. This one, both is symmetric. Both of the charges are pulling away from carbon, the central. There's no lone pairs on carbon as well. So then there's no dipole. It's symmetric. Both of the end elements are the same, which is oxygen. All that contributes to symmetry, and it's bipolar. Everything's contributing to it being non-polar. So it's not polar, non-polar. Let's see, and then for the back, I filled out the table. Number of valence electrons, which is the number of electrons on the outer shell of each element. Carbon is 4. B is 3, Be is 2, Li, lithium is 1, nitrogen is 5, oxygen is 6, fluorine is 7, neon is 8. Again, so each number of valence electrons left is going to correspond to the dots in the Lewis dot structure. So 1 valence electron means 1 dot. 2 valence electrons means 2 dots. 3 valence electrons, 3 dots. 4 valence is 4 dots. 5 valence is 5 dots. 6 valence is 6 dots. 7 valence is 7 dots. 8 valence is 8 dots, which is a full happy octet. Let's see, how many valence electrons are present in each of the following substances? So I drew them out using the Lewis dot structures. I guess I might have not had to, but I went ahead and did it anyways. But you could also do it the math way. So sulfur, or S, is 6, Cl is 7 for each one, and then there's 2 of them, so 6 plus 14 equals 20. And then HCN, 1 hydrogen, 4 carbon, 5 nitrogen. I also drew it out as well. And then this one would be the more correct because it has 3 bonds. It's going to give more bonds to nitrogen so it can fulfill the octet rule. Oxygen only needs 1 bond because it can only hold 2 electrons maximum anyways. So you take the 2 lone pairs and you bond it with carbon to equal a triple bond. But either way, there's 10 valence electrons in HCN. And then CO4 with the -2 charge, this is an anion because there's a negative charge. I drew them out as well. I put 4 because I know there's 4 oxygens. So sulfur equals 6 valence electrons, oxygen equals 6 valence electrons, but you have to remember there's 4 electron atoms, and you also have to add the negative charge extra here that's making an anion for a grand total of 32 valence electrons. Let's see, and then next page. Okay, so the formal charge on an atom equals the number of valence electrons minus the number of lone pair electrons plus half the numbers of bonding electrons. I use this way because it's just easier for me. So formal charge equals valence electrons minus, and then I refer back to the Lewis dot structure of bond plus dots, and you want it to be the closest to 0 because that's going to have the molecule be more stable. Kind of like how I did right here, calculate formal charge on each atom for CO. So I did it for carbon here. C equals 4 because it has 4 valence electrons minus 3. 3 is the number of bonds right here, 1, 2, 3, plus 2, which is the number of dots right here on carbon, equals 4 minus 5 equals -1. I put a negative charge by carbon. I did the same with oxygen. O equals 6. 6 is the number of valence electrons. Minus 3, 3 bonds, plus 2, 2 of the lone, of the electrons, the lone pairs basically, or the dots, equals 6 minus 5 equals 1. It's a positive. I put it over the oxygen. So -1 with +1 equals 0. It cancels each other out for a charge of 0. Let's see, so Lewis dot structures for H2O, there are 2 pairs, there are two lone pairs on the central atom, oxygen right here. This is 1, this is 2 lone pairs. The molecule shape will be bent because there's 2 lone pairs on oxygen repelling the H atoms. BF3, there are 0 lone pairs because you look, there's no lone pairs, no extra dots around it. It is a trigonal planar because B has no lone pair, so nice, even. For the molecular shape, I don't have it memorized, so I just refer back to the diagram in the textbook. There's also diagrams available in the lab document as well. And so yeah, I don't have it memorized, but that's what I refer back to. So XeF4, there is 2 lone pairs in the central atom, because there's 2 here, 2 here. Xe is able to violate the octet rule because it has 12 electrons around it because of the lone pairs 1, 2. It's able to expand due to availability of d orbitals, which allows it to hold more valence electrons. The molecular shape is a square planar because it's 4 single bonds, 1, 2, 3, 4. And it also has 2 lone pairs on it, the central atom Xe1, 2. PXL5, it has 0 lone pairs, no extra dots around it. It's nice and happy. It's able to have 5 bonds because it's able to expand octet to d orbitals, because it has d orbitals available. The molecular shape is a trigonal pyramidal because it has 5 domains, 1, 2, 3, 4, 5. Let's see, SF6, it has 0 lone pairs on central atom, because if you look, 0 lone pairs, no dots, no extra dots or anything. Everybody's having full. Sulfur has 5 bonds as well, and is able to, because of the d orbitals. The molecular shape is octahedral. Let's see, and then molecular geometry. CO2, I drew the Lewis dot shape. The lone pairs, it has 0. I threw in the fact that each oxygen atom has 2 lone pairs per oxygen. There's 4 bonding pairs of electrons as well, because look, 1, 2, 3, 4. So yes. And then, oh, that's it. Oh yeah. So B right here. Oh, what am I saying? So four bonding pairs. Yeah, 1, 2, 3, 4 right there. For CO2. Now I'm gonna do BCl3. So this one has 0 lone pairs on the central atom, no extra dots or anything around it. It has 3 bonds right here. Number of bonding pairs of electrons, 1, 2, 3. Let's see, and then next is NH4 plus. This is a cation because it has a positive charge. I did the little brackets and whatnot, did that positive charge. There's 0 lone pairs on the central atom. As you can see, nitrogen has no extra lone pairs or anything. Nice and happy. 2, 4, 6, 8 electrons filled. It has 4 bonds with the hydrogen atoms. 1, 2, 3, 4. 4 bonds. And then H2O. It has 2 lone pairs on oxygen right here. 1, 2. So 2. And then it has 2 bonds with hydrogen. 1, 2 right here. And it is in a bent shape. Next is SF4. 1 sulfur molecule, 4 F molecules. It has 1 lone pair because of these 2 dots right here above S. It has 4 bonds, 1, 2, 3, 4 with F. And then next is XeI4. So Xe has 2 lone pairs, 2 right there, and it's able to do that because, like I explained before on the last page, it's able to expand it's able to actually violate the octet rule because of the d orbitals. 1, 2, 3, 4. There's 4 bonds with I, so 4 bonds. And yep, that is it.